Hello everyone. Welcome to this stream. And today we are going to just refactor our crochet engine. I have been working on this engine for a long time now, and it has seen some developments. And like I have this prototype ready right now, and uh, as you can see, I have cube maps working. I can disable those, and here I have a cube map, a default cube map, and here you have an option to unlock your camera. You can press the Z button or the Z key to unlock your camera or lock it, and if you lock it, you cannot move it around. And for moving your camera around, for looking around, you just have to hold the right click and just move your mouse. And here I have an option for enabling the hierarchy window, and there is a property inspector and an option to enable or disable the cube map. So here we can use the hierarchy for adding game objects. So right now I have this one. I'll just get rid of this. Okay, so this is a model that I have loaded, and right now we don't have any lighting implemented. So we can add lights to our scene by just clicking this button for adding light. So here we have our first light object added. So after clicking or selecting that light, we can just move it around using the gizmos. For the gizmos and the UI that you see, I have used immediate mode rendering. So for the UI, I have used IMGUI, Dear IMGUI, and for the gizmos, I have used IMGizmos, which is an API for immediate mode rendering, and IMGizmo is based on IMGUI. So yeah, it gives you option for like rotating, scaling, and translating the object here and there. So let's make it a directional light. I'll just position it, let's say, really far away. Let's put the Z position as 0. You can see it's up there. And now what we can do is we can just change the ambient contribution. Let's do it to 0.2. Like we can see it changed immediately, like when we change the ambient contribution here. And obviously we have to change the direction of the light as well. Actually, I have to hook up the position of this with the direction as well. Right now we'll just have to use the manual method here. So it is yeah, let's do it -1 on the x-axis, -1 on the y, and let's do 0 on the z. Now it's perfectly shining based on the position of the light. And let's reduce the diffuse contribution to 0.8. Here we go. And now we can already see the details on this model and the specular reflection and all. Right now I have implemented basic BRDF, which is basically taking the specular and diffuse contribution and just normalizing them by their respective factors. Like the color of diffuse is divided by the factor of pi, energy conservation and all that stuff. And let's add one more light. This will be a light one. Let's make it a point light, and let's scale it down a bit. I'll just make it roughly a cube. it still is a bit buggy, but it works. Now let me position it, let's say around here. You can see like as I move the point light, the specular reflection and all also changes accordingly. So let me turn down the ambient contribution to 0.2 and the diffuse contribution to 0.8 as well. These are just default values that I have just tried and tested. I'll just leave it around here. And maybe we can just bump up the attenuation constant a little bit. That's attenuation is basically like the intensity of your light gets lower and lower as the distance increases. Like it's proportional to the inverse square law. Like it's proportional to the 1 by the distance squared, and it follows the inverse square law. And we can also add a linear factor to it as well. So let me do this to make the specular bit softer. Here we go. We can see we have a directional light, a point light, and yeah, we can even add more objects and more light sources. We also have an option to create a spotlight. Let's add another game object. Let's position it somewhere around here. Let's position it around our point light source right here, and maybe we'll change the material property a bit. Let's do the ambient to be a bit darker, like so, and the diffuse would be a bit brighter. You know what, let's make it a different hue. We can choose this one maybe, and for the diffuse as well we'll get that, and specular stays the same, and we can change the shininess factor to let's say 32. Here we go. We can see the specular highlights from the point light on the cube as well, and from the directional light as well. Let's rotate the cube a bit, like so. As we can see, this is the basic part of the game engine, just a renderer and property inspector, hierarchy and all. Currently I don't have scene graphs implemented for managing my game objects. I'll do that soon, but right now what I'm doing is I have a generic class of game object, and I am storing a pointer to that in a vector, std vector. And yeah, just I have used polymorphism for lights and game objects, so they have inherited properties from the main game object class, but they do contain their own separate properties which are different from each other, and that's how I manage these game objects. So yeah, this is the crochet engine which I have made so far. Like, it has taken a lot of effort and I am building it, but like while building it, currently the code is a bit messy, and I have used hacks here and there in my code base, so it is all cluttered up and mixed up, so it's not a good code base to work on. So today I'll be refactoring, rather I'll be rewriting the whole engine, like till the current state, and let's see how it goes. I hope my audio is all right. I hope my audio is all right. Yeah, it's fine. So let's dive into the refactoring part. So currently Crochet engine is, I would say, in version alpha 1.0, and I just cleared out the previous whatever things I did. I just want to rewrite it from scratch again. This won't take much time, I think, but let's see how it goes. Maybe I'll just add a desklet for showing our to-do list, like what are we going to try to do in today's stream. I'll just add that and we'll begin then. That's not visible. Let me add a text element rather. That would be much better. So we'll be writing an OpenGL wrapper uh, for the low level stuff, and to make it easier for using it in our engine. And let's say we'll create a basic rendering loop. Basic rendering loop means like we'll just make it run, maybe render a triangle or something just to debug, and I think that's it. Let's see how it goes, and maybe we can add a few more things as we I'll be right back. So I am back. We have our to-do list in place. Let's start coding. So the idea is that I'll create an OpenGL wrapper first and wrap the basic low-level things into usable functions that I can reuse in my API. And what I'm planning to do is that later on I'll also be implementing the backend in Vulkan, so the user would be able to choose which backend he or she wants to use, like Vulkan or OpenGL. So I'll be writing a wrapper for OpenGL. In the future, I'll be adding a wrapper for Vulkan, and then there would be an API layer which will then choose between these two backend layers and proceed with the rendering and engine stuff. So yeah, let's make um, the include files. Let's write the wrappers first. I'll name it ogl.h and ogl.cpp. I'll be including glad for the OpenGL function loading. What I'll do is start with the shader class first. So shader would be a type basically, and it would be used for loading shaders into our program or engine. So let's start by declaring the private variables. So ID would be used to uniquely identify the shader program, and maybe I'll add a name for it. And let's add a few helper methods in private, so that uh, these methods could be used for loading our file and using compiling the shader and all. So let's write a method which would return std string and name it load file. It would take path for the file, and let's do a function named compile shader which would return unsigned integer, which would be the ID for that compiled shader, and it would take the source code for the shader. And let's also add a shader type. We'll create an enum class for that. Vert for vertex shader, we'll do geom for geometry shader, and frag for fragment shader. Let's keep these three for now. And another method would be to create shader program. So this would glue everything together, like the different parts of the shaders, vertex, fragment and geometry shaders, into one single shader program. And it would take constant reference to unsigned integer, the ID of that shader. And let's do one more of these. When in the scenario where we have geometry shader as well. Here we go. These are the basic methods that we require. Let's go on to public. Write a constructor for our shader class. We could take the name and paths for the shader files together in the constructor, or maybe we can do a separate method for that. Maybe let's do it in the constructor itself. We'll take the name, and path. Let's copy this again in case we want to include the geometry shader as well. Here we go. Then we'll have our destructor. Which will clean up the resources, and let's add a method to use the shader program. This will set the internal pointer of OpenGL for using the current shader program as the shader program for rendering. Then what else do we need? Yeah, we need a method to set uniform values using the shaders. So what we can do is do a template function, and this would be evaluated at compile time, so we'll use const xbar, and so we'll have to define it in the header itself. So let's do it. First we take the name of the uniform variable and then a constant reference to the value that we set to that uniform variable. So let's name it val. Now we'll get the location of that uniform variable using GL get uniform location, and the first argument that it takes is the ID of the shader program, so MID, and then the name. We'll have to convert it to C style string, and now what we'll do is we'll do some comparisons, and based on those we'll set the respective uniform value. We'll use std's same v, which compares the two data types together and returns true if they are same and false if they are not. So we'll compare t with int, and if t is int, then we'll use gl uniform 1I for setting the integer value. We'll first the first argument that it takes is the location of that uniform variable and the value itself. Let's do this for other data types as well. For a boolean value, we'll have to typecast it into an integer and then send it as a uniform variable, because GLSL does not have a boolean data type. It supports integer. Like, that's how uniforms work actually. Now for float, and we'll be using GLM for our math operations and linear algebra operations and all the matrix math and whatever is involved in our program. And let's create a uniform setting method for that as well. GLM value pointer is basically it gives the pointer uh, of the first element of that vector. So we'll be using that, as in case of passing a vector or through a uniform, we require the pointer to the first element of that. Lastly, we'll add a method for setting matrix value. We set the transpose value to GL false, which is an OpenGL internal variable for false. That means we don't want to take the transpose of the matrix while sending it as a uniform. It comes in really handy, like when you want it to be transposed while sending it to the shader. Again, we need a value pointer to the val. Here we go. We have our first wrapper for the type, and for that let's include GLM as well. Here we go. Now let's add definition. Now what we are doing is calling those helper methods that we created earlier into our constructor. So like all of the pre-processing steps, all of those steps would take place when we call the constructor. Now let's create shader program and let's pass in vert and frag. This creates a shader. Let's see. Yeah. Now let's add the constructor definition when there is geometry shader as well. In fact, we can just copy this whole method and edit it. So we have our constructors in place. Now let's write the destructor. Which will just delete the shader program we created, and we'll just pass our ID as an argument to that. That's done. Now we'll write the use method as well. Again, the ID goes there. We go. What else do we need to write? This is in header itself. Yeah, now we'll write these helper methods. Now we need a string variable to hold the source code of our file or the contents of our file, and the file itself will set the exceptions for our file handling. Then let's put a try and catch block. We'll open the file for the specified path. Now we'll create a string stream. And we'll read this the buffer of this file into the stream. We'll redirect it into the stream. Let's close the file, and now we'll set code equal to the stream. We'll convert it to the string format, and let's also write the catch block. Which will just give an error. Let's do it. Reading file, and the reason would be e.what. That's out of the way. We'll just return our code. That's it. Now let's do this compile shader method. We'll create some temporary variables here in success, and the success variable would be used to check if our compilation of the shader was successful, and info log would carry any error messages if we face error during compilation. And let's do one thing. We'll create a variable for the shader, and let's create a switch case block on type. Let's get rid of this, and word. If the shader type is word, then shader would be GL create shader Vertex shader and break. Break. and let's add a default block as well. It will say error not a known shader type. If that's done, let's do GL shader source, and yeah, we'll need to convert this source code into a const char pointer. Here we go, and we'll just add it here. We'll pass shader as a first argument, then address of our source code and null as the last argument. Then we'll compile the shader. Now we'll check if the shader compilation was successful or not, and let's put in shader GL compile status and address of our success variable where the result would be stored, and let's check if success. What we'll do is if not success, then we'll just get the reason for the failure of compilation of our shader. Get shader info log. We'll put a buffer size in bytes, which is 512 bytes, and our info log. We'll be using cerr stream for logging our error because it is not a buffered stream and it just prints out the error message immediately without waiting for the buffer to fill up completely. And yeah, so error message could be error compiling shader. Let's create a string for the shader type as well. Let's name it S type, and if it's a vertex shader, we'll do S type equals vertex. For geometry shader, S type would be geometry, and for fragment it would be fragment. Now we can just mention here which kind of shader compilation failed, and maybe we can just, oh, we did not set the name for our shader in the constructor. Maybe I had it here, so let's add that as well. And we'll just put it in the initializer list. Here we go. Let's add it to our second constructor as well. Here we go. We have the name of a shader program. Now we can do error, and let's put it in a bracket. Let's put mname, error compiling, and let's do S type. And let's put the reason, which would be our info log. else we'll just print um, success creating, compiling shader. um, let's add which shader we are talking about, S type, and let's add the name of a shader program as well, so we know which shader we are talking about. Here we go. That looks good. And now we are free to return our shader object from this method. Yeah, it looks great. We'll check for any errors later. And then let's just copy this method. We'll use GL create program, and we'll store that ID store the ID that it returns into our private member variable MID, and let's use GL attach shader to attach the vertex and fragment shader to our shader program. Then we link the program. Let's create some temporary variables. GL get program IV, MID, GL link status. If not success, we'll get the reason for failure of linking the shader program. GL get program info log. We'll specify the size of our info log in bytes, null, and the info log itself, and then we'll use the C error stream for printing our error. Linking shader program. Later I'll use some design patterns to add logging and color coding as well. I have one template ready, like I created it long ago, but it's not so perfect, so I'll create it from scratch later. We have that in place, and if the creation of the shader program was successful, we can just log that success. We'll just use this success creating shader program. Yeah, and after we are done creating the shader program, we must delete our shaders that we earlier created. Delete shader. Let's get back to it and let's copy this. And now we'll have to create a create shader program method where it also includes geometry shader. And we need to do GL delete. Yeah, so we have successfully created a shader type. Let's push it to our repo. Shader type. So we have a shader type in place, and maybe let's add the vendor libraries. For now, let's not create any wrapper for window creation. I'll just cram it all up into a main program for testing our implementation. So we'll be using GLFW for window creation and management, state management. Let's create some macros for this window width and height. Later I'll add methods for probing the screen size directly, and then it will just dynamically generate that. But for now, we'll just use it as macros, and we'll have to define some callback methods as well. This callback method would be used for setting the viewport. So like let's say if you update your window size, then this callback method would be called, and it will call GL viewport, and it will update the viewport size for OpenGL internally. Let's initialize GLFW. And let's set window hints. So here we'll be setting the context version minor and major for OpenGL. This is basically telling that we'll be using OpenGL 4.6. And we'll also specify that we are using the core OpenGL profile, so we'll not be using those deprecated old OpenGL methods. And now let's create a window. So those of who you are watching right now, like I made my crochet engine and implemented lighting, PBRs and everything, but the code was a bit messy, and I decided to rewrite most of it again, and let's see how it goes. So we'll create a window. Let's pass a width, height, and let's define a macro for the title as well. Other arguments are for full screen mode and getting a primary monitor, like we can select which monitor to select, but we'll just go with the default for now. Let's check if our Windows creation was successful. If not, then we'll just error. Now we'll set the context to current. So basically it will set the frame buffer of the window as the current context for rendering, stuff, and OpenGL will use this default frame buffer provided by our window as the default frame buffer for rendering. And now we can load glad for a function loader. We can do one more thing, like if a window creation was unsuccessful, then we can do GLFW terminate. We'll just terminate GLFW. Similarly, we'll also terminate in case we fail to initialize glad, and we'll also destroy the window, and we'll pass the pointer to window, and we'll also do a error log. I'll just show my engine in action to you guys who are joining right now. So here you can see my game engine. So basically we have cube maps working, and you can see the frame rate on top, and it's taking about approximately 6.9 milliseconds per frame, and you can unlock the camera and move around, and we can also enable hierarchy and property inspector. So let's add a game object. We have our first game object here, and we can move it around. Right now it's a bit buggy, like we have this cube like merged with a model. I'll have to fix that. And we can also add light sources. So let's say I add this light source, I just move it on top. I have implemented gizmos. Maybe let's scale it a bit. I'll put it on top like so. And currently you can see the lighting is a bit off. So let's set the light properties here. We'll set the ambient contribution to 0.2 for each color channel. Here we go. And the diffuse contribution to 0.8. And the specular would be 1 as always. And let's set the direction here. -1 along the x, -1 along the y, and 0 along the z. You can see the specular reflection on the object and the details on the object, and it's changing in real time dynamically as I move around, and my viewing angle changes. It's all done in real time. Let's add another light source. We'll create it as a point light. We can see that already as we move this point light source, the specular reflections changed accordingly, like so. Let's put it here. This is a sweet spot. Again, I'll change the specular ambient contribution to 0.2 for each channel, and 0.8 for the diffuse contribution, like so. And we can see lighting working in action. We can also disable our cube map, and to enable wireframe mode we can just press T and we can see all the mesh that is being rendered. So this here is a sphere with a cylindrical cavity in the center, and this is our directional light source. This is our point light source. Here we go, and let's say maybe we add another game object. Let's place it next to our point light source, and maybe we'll change its material properties a bit. Let's choose the ambient color. We'll choose it to be roughly this shade of yellow, and let's choose the diffuse shade. Let's choose it a bit brighter, like so, and we have the specular. And right now the shininess factor is set to 1. That means it's not so metallic. Let's change it to 32. Like, these values are some values which I have tested in the past, and these work out really well. Now you can see the different lighting and shading, the specular reflection as I move around in action, and maybe let's rotate this a bit. So yeah, this is what the engine features right now. There is a lot to write, scene graphs and everything to be implemented, but yeah, we'll slowly get there. And currently I'm in middle of rewriting most of the subsystems of my engine, so let's get back to coding. We initialized glad. Now what we can do is let's create wrappers for buffers as well, for creating the vertex buffer objects and vertex array objects. So let's start with the VBO abstraction first. So let's define the private member variables first. It will be unsigned int ID, and let's also give it a name. Let's do a constructor for this. Which will take name as an argument. Let's create a destructor, and then methods for binding our vertex buffer object and unbinding it. Here we go. And what else do we need? We need a method to allocate memory on the GPU. So we'll do void allocate and fill memory. So here we need the usage, like our GPU has different kind of buffers. So OpenGL has these enums for defining those buffers, like whether in which buffer we want to store them. So there is a static draw buffer and a dynamic draw buffer. There are other buffers as well, but these are the ones which are used quite often. So static draw is like you just upload your vertex data onto the GPU once and you don't update it at all. So it's just lying there on the buffer, on the memory. And other is the dynamic draw, which allows you to update the vertex data on the buffer, and it actually does that. Buffer is easier to access and modify, so it reduces some overhead. So that's why we have that. So we specify the usage, then we need a size. Let's do size and the data itself. So const void star data. Let's create a separate method only to allocate memory. And let's specify the size. The first method that we created was allocate and fill memory, so we just allocate some memory on the GPU buffers and just fill it up with any data we have. And we have allocate memory method, which is the second variant, where we'll be only allocating the memory. And let's create another method for filling partial memory. So this will take size, then offset, and data. I think that's it. Let's write definition for it. In the constructor, we'll call GLGenBuffers for generating a buffer object. So this object will manage our buffer on the GPU. And we'll also write the destructor. And let's write the bind and unbind methods. Let's also add a enum variable for storing the type of this buffer, because we'll be having EBOs, VBOs, UBOs and other buffer objects, and we need to differentiate amongst them. So we'll just add this as well. And for VBO we have the type as GL array buffer. So we'll just put the type as our target, and we'll bind our MID or our vertex buffer object to this target, that is GL array buffer. Let's write another method for unbinding it from that specified target. 0. So 0 just unbinds whatever is currently bound to the specified target. Let's write this method. GL buffer data, and we'll put M type as the target. Then we have the size. Then we put the actual data, and then we put the usage. That's it. Now let's do for allocate memory. L should be capital here. So here we'll again use the GL buffer data. This method will bind it to that, will add it to that target. We'll specify the size, but in case of the data field, we'll just add null. So we'll just allocate the memory, and we will not populate the buffer with any data. Here we go. And for filling partial memory, we'll use GL buffer sub data. We'll specify the offset, the size, and the data itself. Here we go. I think That's it for our VBO class. Let's write our VAO implementation. Now we'll write the set attribute pointer method. And here we'll take integer for the location. Then we'll take integer for the number of values. Then integer for the stride value. And integer for start. We can later add draw options as well, like we'll just specify shader as an argument to that draw method, and VAO will draw whatever buffer is bound to it. Vertex arrays. It should not be a void, it's a constructor. We have that. Let's write the bind and unbind methods. So this set attribute pointer method, it specifies like in what format our attributes for the vertex data are going to be sent to the shader. Hello Abhas. Abhas is asking when will this engine be completed. Abhas, I don't know, like there are a few features to be implemented. Currently I have the version of engine running, so currently I have created a renderer, but right now I am just refactoring it and rewriting some part of my engine. It will take some time. Like if you want to see, I'll show it to you what the current state of my engine looks like. Here you can see it is supporting cube maps, and you're able to move around. A camera system is implemented. We can enable hierarchy, adding game objects. We can add light sources. We can edit the properties. And it is doing all of these things in real time. So currently I have implemented model loading and GPU skinning as well. So model loading is just, as you can see, this model loaded here, and we can just move around stuff. And this is basically a renderer created for game engine. I am also writing a scripting system. Maybe it would support Lua as a scripting language, or maybe Python. I'll figure that out. And right now, like, we can add multiple light sources. You can see the specular reflection and all moving in real time. So right now we have a directional light. Let's change its direction. Let's say -1 along x-axis, -1 along y, and 0 along z. You can see the reflections change as we move. And let's say I want to add another light source. So this is a point light. Let's turn down the ambient contribution right here. Like so. Now if we move this light source, it should move the specular highlights. Oh, it's a directional light still. I'll select point. Yeah, you can see, like, when I move this point light, it changes in real time, the reflections and all. So this is the current stage of my game engine. So currently I have created a renderer. Maybe within 2 to 3 months we'll have a basic engine ready wherein you could lay out the maps for your game, and maybe write a few scripts for moving game objects here and there. I was also working on a physics engine, which is actually a submodule of this crochet engine. It is called Newton 2D, and it will simulate physics in real time, because games are nothing without physics. So yeah, so let's get back to coding. And by the way, this is created from scratch in OpenGL and C++. Yeah, adding physics is kind of difficult, but yeah, you just, like, my current implementation supports Newton-Euler integrator and some basic physics equations for adding force and velocity to any game object. So guys, it's dinner time for me. I'll be back after dinner. Till then, you can listen to some music. I'll just play some music. And I'll be right back after dinner. Hello, hello, hello. We are back once again and we'll continue from where we left off last. So, uh, those who don't know, we were writing a wrapper for OpenGL functions, and like last time we were working on the set attrib pointer method in our VAO class for vertex array object, and let's continue where we left off. So we completed writing our shader class implementation, our vertex buffer object or VBO class implementation, and we are on VAO or vertex array object class implementation. So let's get going with it. So this game engine I am working on, um, we are just rewriting some of the modules of the game engine, the backend, which is in OpenGL. We are going to rewrite it, and I am planning to include backend for Vulkan as well, and maybe DirectX in the future. So while using the engine, the user can choose whether he or she wants to use OpenGL, Vulkan, or DirectX backend, and there would be a main abstraction API for the Crochet engine, which will then use the selected backend for rendering and other stuff that we'll use in our engine. So first of all, I have used some of the C++ types here, like size underscore t, but I think it would be better if we use the OpenGL internal types. So let's change those. For size, it is, I think, GL size I pointer. Let's change it here as well. For the offset, it is GL int pointer. Uh, well, GL size I pointer is basically it allows to specify the size of that buffer, uh, which ranges from 0 to up to whatever you want to allocate, how much ever the hardware allows you to allocate. And the GL int pointer, it's basically an offset, and it allows you to also specify offset in negative integers. So that's why there is this specific internal data type for that. So we have changed that there. Okay. Now let's change it here in our definition file as well. I hope I am audible. My microphone gain seems to be perfect. and let's again specify GL int pointer for the offset. Yeah, we are done with our VBO. Now let's go to the set attrib pointer method. So first we will enable the vertex attrib array at the specified location. Here we go. And then we will set the GL vertex attrib pointer, and it will take location, then number of values that it will take. So let's say we are specifying the vertex data here, and location is like which location we will fetch that particular attribute. So basically, let's say a vertex has three attributes, like it can have more attributes as well. So the first is like the position of the vertex, like in the given coordinate space, and second is the vertex normals, like each vertex can have its own normal facing in the specified direction. And also let's say we have a vertex color. So let's say we are drawing a quad with, or a square maybe, and we specify a color for each vertex as a vertex attribute. Then what OpenGL does is it interpolates between those two vertex colors and gives you a nice gradient between those vertex colors, and what you get is a mix of RGB kind of thing, a gradient. You can also change that gradient function. So let's continue. Now stride is like basically the amount you should move in the array in order to get to the next vertex data, and start is basically the starting point of that vertex data. So we have that in place. Let's also consider changing, or maybe we can leave it as ints for now, right, like we have done it right now. I'll just add a few comments here to separate different implementations. This is for our shader. Let's go down. VBO. And here we have our implementation for VAO. Here we go, that looks okay. And now let's go to our main loop. Right now I have not created any abstraction for window manager and all. We'll do that eventually. So let's create a float array, maybe float vertices, and specify vertex data for triangle. We'll just check if our current implementation is working right. Let's specify it in NDC, normalized device coordinates. Let's say we put it around -0.5. For now we'll just specify, or maybe we can also specify the color attribute of vertex. So let's say the first vertex, which is on the bottom left, it would be colored red. We specify the color in RGB, and Here we go. Now what we'll do is we'll create a VAO. We'll name it VAO as well, and we'll create VBO, and we'll name it VBO, and we'll also specify the name for that. Let's say triangle VAO and triangle VBO. Now what we need to do is we'll bind the VAO, then we'll bind our VBO, so they both get associated. And let's say we allocate and fill our memory, VBO dot allocate and fill memory. Let's check what attributes we need to specify: the usage, the size, and the const void pointer. We'll do GL static draw, and for the size we'll do size of vertices, and we'll pass vertices. Let's make it a const. That's done. Now let's do VAO.unbind. Now let's set our callbacks, like the one we created a callback method for the frame buffer size callback. So it is called when you resize your window scale. Let's set that. Now let's write our main render loop. We'll poll for events like any button presses and all, any inputs, and let's set the clear color. Clear color is basically the color with which your color buffer would be cleared with. So let's set it to black in RGB. Then we'll specify GL clear with whatever buffer we want to clear. So GL color buffer bit, and let's do VAO dot bind. We'll bind our VAO, and let's do GL draw arrays. We'll specify the primitive, which is GL triangles. We'll be using triangle as a primitive for drawing our geometry, and then it takes 0 and then 3, which is the number of vertices. Here we go. After drawing that, we'll just unbind our VAO. Then we'll just swap our buffer. What GLFW swap buffer does is basically we have double buffered rendering enabled by default. So it is like while you are seeing the things rendered on the front buffer. So let me show it to you, maybe on a whiteboard. Yeah, I hope you can see it. So what this is basically, OpenGL provides you, like, GLFW is enabling double buffering basically. So let's say this is your front frame buffer and this is your back frame buffer. So this is the thing that you can see rendered on your screen. So let's say you are viewing something, maybe mountains or something like that. Forgive the drawing here. And now what happens is, while you are seeing this image here which is rendered, OpenGL just renders to the back buffer. This is the back buffer, and while you are seeing this frame, the next frame is being drawn here. Let's say the mountain somehow enlarges, and it is like this now, maybe a zoom in kind of a effect. And now what happens is, once you see this, Piyush is asking, do I need a graphic card in laptop? Do you mean for running my game engine? Yeah, so coming back to this, after you have seen this frame and things are rendered to the back buffer, the swap buffer function just swaps these two frame buffers so that you see the next frame, and this front buffer becomes the back buffer where the new image is rendered. This is done so that you don't see the artifacts while the next frame is being rendered. So let's get back to coding. Yeah. Piyush, the context is not clear. Like, in which case are you asking about the graphic card? Like, if you are asking if do you need a dedicated graphics card for running my game engine? Yeah. No, you don't need a dedicated graphics card for running my game engine. Uh, it will work just fine if you have the integrated graphics that comes in any modern CPU. You don't require a dedicated graphics card. Yeah, so that done. Let's do and let's return 0. Yeah. Yeah, now one more thing that we need is shaders. So we created a shader type. So let's create basic vertex and fragment shaders. What I'll do is I'll create a folder named assets, and in that I'll create we'll call our vertex shader as vert.glsl, and our fragment shader, you are welcome Piyush, frag.glsl. Yeah, so we are writing our vertex shader now. So we'll get a vec3 for position of our vertex. This is the first attribute. Let's specify the second attribute. We specified the vertex color as well. So we'll name it as a color, and let's write the main function. Right now I am not using any projection or view matrix as such. We are just directly dealing with it in normalized device coordinates, just for testing if our backend implementation works right. So that's that. Now we'll send out the color that we received as an attribute to our fragment shader. So we'll use the out keyword here, out vec3 color, and let's set color to a color. And in our fragment shader we'll have to specify in vec3 color, so it knows that the color is a variable that we'll be receiving from a vertex shader. Here we go. We have implemented basic shaders, and now yeah, let's specify the name. Let's name it triangle shader, and let's specify the file path. I'll be setting this path relative to the build directory, which I have not yet created, but soon I will. We'll do assets and vert.glsl for a vertex shader, assets and frag.glsl for a fragment shader. And before we do our drawing call in our render loop, background music, bro, the background music is listed in the description. Check the description for that. We'll do shader.use. That's it. Now let's write a CMake file. Hi Lucky. So Lucky is a game developer. Hi, nice to meet you. So, are you working on any game right now? Like, do you have any project you're working on? Let's include fetch content and fetch content declare, and let's fetch GLFW, and let's specify the git repository. Lucky, please no self promotions here. Um, so let's specify the link. So Lucky, are you using any game engine or are you writing it from scratch? What is it? Hello Vivek. Vivek is asking, what is this? So this is basically a custom game engine that I'm working on. I'm making it from scratch in OpenGL and C++, and I was in the process of refactoring and rewriting some of the parts of the game engine, and that's what this stream is about. Yes, Lucky, that would be the next priority. Like, first priority is getting the rendering and basic game engine stuff in place. After that is in place, then I will be working on making it multiplayer and networked, like just like Roblox, but it will have some extra features like that I have not thought about much. Do you guys want to see a demo for this engine, like what I have built? If you want, I can just quickly fire up my game engine and show you what I have implemented till now. Okay, so I'll show you all my game engine. As you can see, um, there is not much of things implemented here. This is a basic renderer that I have created for my game engine. So unlocking the camera allows you to move around, and you can enable hierarchy and property inspector. And let's say I add a game object. I just move out a little bit, and you can see this game object is added into the scene. Now it looks a bit plain, and no reflections, no shadows, nothing. Now what I'll do is I'll add a light source, and this lights it up, but the light isn't quite right. So let's set it up properly. So this is the light source. We can just move it around. Let's say I place it in this direction, and let's change a few properties. This is a directional light. Let's change the ambient contribution to 0.2 for each RGB channel. Lucky is using Unity engine. That's cool. That's cool. So diffuse is set to 0.8, and now you can see, let me change the direction of the light as well. You can see as I move around, the specular reflections, they change according to the viewing direction, and the light source is up there like so. And let's say I add another light source. Let's make it a point light this time, and again I'll change the ambient contribution to 0.2 from the property inspector. And let's say now I move this point light. Let's say I move it here, so you can see the lighting is changing in real time here. As I move this light source, and the reflections are changing accordingly. And let's say I want to modify the scale of the light. I can do that quite easily with the gizmos. Haha, lucky no. I don't use any game engine. Um, I am making it from scratch. Like earlier, I have made a few games. I have used Unreal and Unity in the past, but the thing is that um, I don't like some aspects of those engines. Like they are great, but they are too generic, I would say, and that makes it a bit slower. So let's say if I make a game using my game engine and using Unity or Unreal Engine, the same game using the same assets, the game which I make in my game engine would run 6 times or 5 times faster than the one which is made in Unity and Unreal, because the game engine that I am making, it is going to target a specific genre of games, and Unreal and Unity on the other hand, um, they are trying to cover up each and every genre, which makes it not so efficient for each kind of genre, if you know what I'm saying. So this is the light source and all, and we can see the wireframe view like this. So like if you see, like many of the AAA game titles, they have their in-house game engine implemented. Like they don't use Unity or Unreal. Nowadays, maybe some of the AAA titles are using Unreal, but they customize the engine's backend according to their game's requirements. So yeah, many of the AAA game companies, they write their own game engines from scratch for their games. So that makes their game quite performant. Yeah, exactly. Let's get back to coding. Let's make GLFW available after we fetch it. Then we do find package, and what we need to find is OpenGL, and it is required for running our application. Then let's add a subdirectory. That's impressive, Lucky. Modifying GTA 5, it's impressive. So what kind of mods were you working on? Okay. But what kind of mods have you done in GTA 5? Like, is it related to game modes or something? Let's add executable. So Lucky, are you still there? Ah, you're talking about the menu mod of GTA 5. Yeah, that's a cool one. Great job, Lucky. I added the main file into vendor folder by mistake. Let's take it out. Now we'll link libraries. I think that's it. Let's create a build folder. Let's run cmake. Let's build it. So we have got two errors. Okay, so this is glad include error. So let's check the source file for glad. Yeah, we need to make this right. Few more errors. Glad no such file or directory. Okay. Which part gives this error? ogl.h. Okay, we need to add that in the include directories. Again a few errors. glm not found. Okay. Let's link it with glm. Does it find the subdirectory glm though? Lucky, as I said, no self-promotion on the stream. You're free to discuss about your projects or what you're working on, but please no self-promotion here. Okay, now we have some different errors now. Let's try to fix those. GL size pointer has not been declared. Okay, so there is a typo. This should be GL size I pointer. And no declaration matches void VBO allocate and fill memory. Okay, we'll fix that. Okay, so we are missing the size while argument in that. We'll fix that. Okay, it's basically the type error. Be GL size I pointer. Size I pointer. Same here. In member function, okay, too few arguments to function. Okay, yeah, we'll have to specify the size. Like right now we are just specifying the number of values here, but we also need to multiply it with size of float. And this should be typecasted to a void pointer. Okay, this is all right. I don't think we have set the attribute pointers right here. Yeah, no. Let's set those. So the first attribute is our position, which takes 3 values, and the stride would be 6 and the start value would be 0 for our position, and for our colors it would be the same, just the start value would be 3. Okay, let's build. We are getting a few more errors. Invalid conversion from void star to GL boolean. Okay, so we missed one part, that we also have to specify the type here. GL float, and for the normalized argument we'll put it as false, and let's try compiling it again. It should work. Nope. No matching function for call to VAO. I think we did not specify, yeah, we did not specify the name argument in this constructor. Let's make changes here as well. So we have our basic engine running. Let me show it to you. Yeah. So whatever we have written so far, the abstraction or the wrappers for our shaders, it is working, and as you can see we have a triangle rendered on the screen. This is just a simple thing to render at first so that we can check if our program runs alright. And this is the thing about the color interpolation that I was talking about. As you can see, for this vertex I have specified a red color, this vertex is blue, and this is green. And what OpenGL does is it interpolates these colors along different positions. So as you can see, there is a blend of red and blue here, blue green here, and red and green here, and all three mix to a little bit of whitish shade in the center, like so. Yeah, now it's working all right. Let's check the logs. Okay, everything's all right. Now let's write a few more abstractions. One abstraction that I feel we should write is for the textures, for loading textures. Let's make this, let's define private member variables. As always, it will take an ID, a name, let's create a few methods for loading texture. And let's do public and create a constructor. We can create a texture type for loading cube maps as well as normal 2D textures, but I think we should segregate those into different types. So for a simple plain texture, I'll create texture 2D. Let's create a destructor for that. Do you guys want to see a few other projects that I have made with using my game engine? Like the renderer which you saw earlier was um implemented for demonstrating lighting part of my engine, but there are a few other implementations where I implement animations and all. If you'd like to see that, just let me know. Okay, Ansh wants to see it. Let's just wait, I'll open my project. Let me show you another project. As you can see, this is called Hell Slayer. This was one game that I was working on using my game engine, and yeah, this has a proper implementation of GPU skinning, where you can see the model is being animated. Uh, right now, game mechanics and all needs to be implemented, like the camera system is not so great, and the player can just move around and the animation just loops continuously. I need to fix that in order to make it event based. So I was planning to create a data structure basically to handle different events, like let's say a player is walking and player is jumping, like all those different events that are possible in a game. Um, that all can be done, and I was also planning that I'll implement interpolation between these two positions. So if you have seen that in many games, like let's say a player is shooting while walking, player might be jumping while running. So these animations, they don't seem to be individual pieces of animations. They are blended in quite well. So that is the thing that I want to implement next in this, so that when player transitions between two different sets of animations, then there is a smooth transition created. So this eliminates the need for creating separate animations for the transition. Rahat, Rahat is saying, uh, I don't know you, but hope one day your game engine will be better than Unreal Engine. Thank you so much for your kind words, Rahat. We are, let's say, if we uh, try to achieve that milestone, we'll surely reach that milestone someday. But we'll, when we reach that, we'll have a first Indian game engine to beat Unreal Engine, if that makes sense. Yeah, I have a few more projects. I'll just show it to you guys. So here is one more uh, project, or I would say rather it is a module that I am working on as well. So this is a module for crochet engine. So as you can see, this is basically for the 2D part of the crochet engine, and basically I have loaded in a texture atlas where all the tiles or all the possible you know, building blocks of the game and its map are put together in one single texture, and basically it allows you to select each tile and then you can switch to the main grid, which is the map. It is basically a map creator for 2D games. And let's say I select this wall here, I can just lay down this like so, and let's say now I select the floor, I'll just place it like so, and maybe let's put a door here and the open door right here like so. And let's say we want some barrels, we might put those as well. Let's just extend this level, put some walls around here like so. So let's say this is our level. it's ready. And this module allows you to export this map that you just now created into your existing project in Crochet engine. Maybe later I'll add a feature so that you can use this tool to upload your map to Unity or Unreal Engine as well. So people who are using other engines can also benefit from this. And now the best part is that you can define a collision layer on top of this. So pressing X enables the collision layer. So right now red color means that these tiles are unwalkable, and the moment you left click on these, it turns green. So this means that these tiles are um, walkable. So basically your players can walk on these green tiles, and this data would be exported in the .ted file or the tile editor file, and it can be used directly in the game using the scripting language, and your player would be able to walk on these green tiles and won't be able to walk on these red tiles, like so. And you can also select animation frames like so. So let's say I select these and I place this here. So you can see the flame animation is playing here right now. So this is from the 2D module of the game engine, the Crochet engine. Ansh is asking, from how much time are you working on this? I mean in game dev. Basically, this engine I have been working on from 2 or 3 months, I guess. I don't remember exactly. And in game dev, I have made a few games in past. Like I have made a top-down shooter game using SDL2 library. That's also a great library. It's used in many AAA games as well. Uh, it's basically used for rendering 2D stuff, and it's made out of OpenGL only. So that was a cool experience. And I have also made a few games using Unity and Unreal, but I prefer making games using my custom game engine or graphics API directly rather than using game engines. I hope I answer your question. So I got into game dev, like basically getting into computer science at IIT Jodhpur was uh, basically led by my interest for games. Like I started playing computer games at an early age, and I luckily, like, I got my first computer quite early, and I was just smashing around keys and experimenting and breaking stuff to understand what not. And games inspired me a lot. Like I wanted to create my own games, and that was the whole inspiration for learning programming and getting into computer science. And I think I am trying to do my best to live that dream. So yeah, I started with programming when I was in 6th grade, and since then, like, I have been trying to implement and learn new things. But it's only recently that I decided to work on my own game engine after using Godot, Unity and Unreal and seeing some issues that they don't solve. Actually, these engines they provide a lot of bloatware. Like maybe if you're working on a 2D game and you don't require some other stuff, then basically that is provided with these engines already, but you don't need them, and they increase the download time, and also it slows down your workings. You get it, right? And it's not so specialized. So what I'm trying to do is minimize this bloatware and provide you with only what is essential. So this is actually open source, so you can modify the source code and change the engine and its features according to your needs. And also uh, I'll be creating modules. Like you can see, this is a 2D module for crochet engine. So let's say you're working on a 2D and 2D game, so you can just select this 2D module and only you will get this 2D module for working on your game. So no need to wait for downloading the complete engine like the 3D modules and all other modules as well. I hope I'm explaining it well. Yeah, Lucky, it's like nav mesh. Yeah, kind of like nav mesh in Unity. So right now, actually, uh, I was reading about PBR and stuff to implement like photorealistic lighting in my engine, and we'll be doing that soon after we rewrite and refactor some of our code base. Ansh is saying I started using Unreal Engine couple months ago, and to tell you the truth, it's overwhelming. And when I see someone like you making your own engine, I get even. Ansh, like I understand, and that's the main motivation behind making my own game engine. You see, Unreal Engine has a really steep learning curve, and it it kind of provide it is acting kind of like a blocker between your creative flow and the lack of programming knowledge, I would say, and that stops you from making creative stuff, whatever ideas you have in your mind. Like let's say there is an artist who has a brilliant idea of a game in his mind, and the steep learning curve of Unreal Engine is stopping him from making the game itself. So the main point of Crochet Engine is to make it super intuitive to learn, so that anyone who doesn't even know how to program can use visual scripting. I'll also be adding visual scripting along with Lua scripting, can work on this game engine and make their own games. And um, no need to get demotivated, Ansh. Like you need to keep on trying. Like making game engines is not easy. Like you have to constantly learn stuff. But I would suggest like you should start with something easier at first. Maybe take a look at Unity or Godot. Try to understand how these engines work underneath, and then maybe you can switch to creating your own custom game engine after understanding how the internals work of these game engines. Instead, you should take it as a motivation that, like, if you are finding the learning curve is steep, then maybe it is a great motivation to start making your own game engine. And maybe making your own game engine, yeah, yeah, Lucky, sure, we can build a community on Discord as well, where I'll be posting updates regularly. Yeah, so what I was telling is uh, there is no need to get demotivated. Always stay positive and try to build stuff, break stuff, and see, it is not that you sit with something and you'll get it immediately. Like I had to, spend hours learning this stuff and creating stuff from scratch. And yeah, it takes time, but you just have to keep at it and you'll get better and better. Yeah, so let's get back to coding now. We were writing the texture class, texture 2D class. Let's write a bind method, unbind method, and we'll also need to set parameters. Yeah, Ansh is right. It's really subjective, but when it comes down to performance and if you want to target a larger range of audience, then maybe using a specialized engine like Crochet engine is much better option because as I said, it increases the performance uh, of your game a lot better than these engines. So like I benchmarked a 2D game made by me. I used the same assets uh, using Unity and using my own engine. Like it was not Crochet engine, but I just hacked the code into a single main file and just made it work. And running a profiler, like I was able to find out that the same game which was made in Unity, uh, it runs a bit slower than my implementation using my engine. So that's the difference, the performance. Otherwise, like all the abstractions and all made in Unity is great, but I still prefer custom game engines. Now we will create a few methods for setting parameters of our texture, like the filtering and all. So Ansh, are you working on any project right now? Any game that you're making? Or do you have any idea about what kind of game you have to work on? And you should keep learning, and maybe we'll create a community on Discord where we can discuss some concepts or some things when we get stuck. That would be great for learning. Good luck with your learning journey. I think this is alright for the texture 2D class. Let's write the definition for that. Yeah, exactly, Ansh. Having a community would be a much better option. Like, we can discuss stuff when we get stuck, and that way you'll be able to move forward quite easy. So for loading our texture image, we are using STB image. It's a header only library which allows you to load almost any image format. We'll be using that. You know what, let's make this method public, because first we'll have to bind this texture in order to load it, right? Or rather, we can just bind it after generating. Yeah, that would be much better. We'll just use bind right here, so that would be perfect. Ansh, for OpenGL, you can take a look at the API reference for OpenGL. I'll just share a link for that. And there is also one book called OpenGL Red Book. If you want that, it will also help you with examples as well. You can take a look at that. And here is the link for the API reference. I'll also link to the Red Book OpenGL. Also, there are plenty of video tutorials on YouTube. If you prefer uh, watching videos, there are plenty, like you can search for them, like OGL Dev. I think OGL Dev is also uploading OpenGL tutorials. I'll also be uploading some OpenGL tutorials on my channel. Right now I have one for FBOs, but that is a bit of an advanced topic. You can take a look at this book as well. Wait. And if you guys show constant support, then I'll definitely create a Discord server where I'll list down all the resources and we'll discuss about OpenGL and other graphics slash game dev stuff. So after loading data, we'll have to set the flag according to the number of available channels. So let's write a switch block on number of channels. So using GL text image 2D, we'll be able to load our image from the texture into this texture object that we are creating. Yeah, Ansh, I'll try if I get time. I'll surely create the server. And let's maybe create a boolean variable for checking if we want to create a map or not. I'm thinking at this point I should put this load texture method as a public method. We'll make changes here as well. Now this is made into a public method. We'll add a boolean. Generate mip maps. You guys want to know what a mip map is? Okay, so I'll explain what a mip map is. Let me clear this out first. Yeah. So basically, let's say this is your image texture which you are using to maybe color your object, and now let's say you are making a game which is running in real time. You have this scenery, let's say, and let's say this object which you have is really far away and you're using this texture on this object. Now what happens is like when an object is really far away, you don't see as many details of that object, right? So the farther the object is, the less detailed it is seen. So if you try to sample this entire texture, this high quality texture into this object which is already far away, and obviously you are going to see less details anyway, so why to waste compute power on sampling this high quality texture, high dimensional texture. Instead what we do is we generate mip maps. So mip map is, yeah, exactly like nanite. So mip map is like basically you create various smaller dimension version of the same texture, and OpenGL internally manages these mip maps, and it uses the right one according to the distance of that object and saves compute power. So let's say if this object is closer, then this higher dimension version would be used, and let's say if it is really far away, then this smaller resolution texture would be used. So it basically saves your compute. That's the mip map for you. After loading the texture, we'll do stbi image free. So we'll just clear out the data that we have loaded. Looks clean. Yeah, now I think we need to create these methods and the bind unbind methods. For this target, right, GL texture 2D, what we can do is we can create a enum right here, like we did for VBO up here, like this, and we can just add it into the constructor, so we don't have to use GL texture 2D all the time. Now let's replace it with M type. Here we go, and we will bind our current ID or texture object to the specified target, that is GL texture 2D. So we are creating methods for writing, not writing, but for specifying the filtering methods and how the texture should wrap around the object. So basically, let's say this set wrap S method. S, T, R are basically X, Y, and Z in the UV space, and the wrap method, there are various wrap methods such as GL repeat and GL clamp to edge. So what happens is sometimes an object uses multiple instances of the same texture, and basically GL repeat allows to repeat the texture once it has filled the space completely, so the texture keeps on repeating. And let's say um, we do clamp to edge, then it basically does not repeat and it is exactly clamped to the edge of the quad we are rendering the texture to. Yeah, so let's set, yeah, we require a value here. Let's copy this. Now let's set min filter. Yeah, Rhythm, we are building a game engine here from scratch in OpenGL and C++. Assassin, it depends on what all features you want for your game engine, and yeah. So if you want to create a basic renderer, then I think um, Exactly. Ansh covers the point. Right now it's been 2 or 3 months. I don't remember exactly. Also, you guys can follow my website. Like I write blogs regarding some tutorials, and also like some of my projects and everything is listed over there. If you are interested, maybe I can link that as well. Um, CPP, I have been learning it for 2 or 3 years, I think. And earlier I was using C, but later I switched to CPP. What do you mean, Shaker? How many software are there to run codes? I have just created a poll. How many of you know OpenGL? So based on this poll, maybe I can decide to create a tutorial series on OpenGL. I have added the link for my website. You can check that. There are some blog posts and also some information regarding my projects. Yes, Assassin, I have used Raylib. I have used it for one project. Raylib is a good implementation, I would say. It's a really great API. I have used it in the past for a 2D game that I made. I'm not sure, but I think Raylib is also it also has some backend of OpenGL. I'm not sure though. Assassin, you can try anything. Like they are just different set of tools for doing the same thing. But I would suggest go with Raylib. Like I am telling you as per my personal experience. Like they are more or less the same, but you also have to see that which one of the API is more comfortable to you. We have written these methods. Now we need to write these methods, setting the sampler value and activate the texture unit. Uh, So we first set a shader to be used, and then we use the shader to set value, the sampler value. So basically what this does is, like while using a texture to sample from a texture, we use a specific sampler. Let's say for sampling a 2D texture we have a sampler 2D, and for sampling a cube map we have a sampler cube. So we write that in a shader file, a fragment shader, and basically we tell the shader or that uniform variable like from which texture unit to expect the texture from. So that's what we are trying to do here, setting the sampler value. Which IDE do I use? Assassin, this is Vim, this is NeoVim, and I have customized it a little bit, like it has custom themes and all, but basically it is NeoVim. You can get it, like it's a great IDE, like it allows you to use minimize the use of your mouse. Yeah, we'll also need to specify the name for a uniform variable here. Yeah, Assassin, it is similar to GVim, but um, it's not compulsory that it is only used for competitive programming, like anyone can use it. We are done with our texture 2D implementation. I think we can test it out. Ansh, you use Rider for Unreal. That's great. I think it's an ID by JetBrains, right? Before using the texture, what we'll have to do is we'll have to specify texture coordinates um, for our triangle. So basically it's like this. Let's say we have this texture and this is our triangle. So basically we have to map these coordinates like say this is 0 0 origin, this is 1 0 and this is 0.5 1. So basically we have to specify these texture coordinates as per our triangle, so that this part of the texture is being applied to our triangle. Right now I am refactoring our engine, and to test it quickly if our implementation is working or not, I am using a triangle, not any complex 3D model. We'll add another attribute pointer. We'll name it as texture coordinate. Now for a fragment color, we will sample from this texture based on the texture coordinate. That's done. So let's create a texture 2D here. Let's name it, let me find a good texture first. I have got a brick texture. I'll just edit it quickly to the right dimensions. Games, Ansh. Right now I don't play much games, but I have Dead Island 2 and Jump Force. I play those two right now. Like, yeah. Let me download it. The texture that I have edited. I was using a web photo editor for that. It's called Pixelar. I'll put it into the assets folder. I'll call it brick. Here we have it. It's called brick.jpg. And the name would be brick texture. So what I'll have to do is buy Ansh. Maybe I'll provide the link for the Discord server in the next live stream. So stay tuned for that. We changed the method load texture from private to public, so I think we should remove that path argument from our texture2D constructor as well. That is not required anymore. Yeah, that's fine. Now let's find our texture. Then we will set the parameters for it. I'll use GL repeat. We are using a 2D texture, so we don't need to set the parameter for R. And let's set the min and max filter to linear. The load texture method also has a boolean. Let's include that. Now let's load the texture. And we want to use web map, so we will set it to true. After that, let's set a sampler value for that. We can just unbind the texture now. Let's set the sampler value to 0. And we need to activate the texture unit here. We'll activate the 0 texture unit, and we will bind our texture to the texture unit 0, and after a draw call we can just unbind our texture. Here we go. We will add a directory for stb into, wait a second. The stb image library, it's a header only library, so we just need an empty C++ file with the macro as stb image implementation. And I'll just get the source code for that library and paste it into the header. Let's add it to our CMake list. We'll have to include it in our OGL as well. Let's include it. I think we made a typo here. It should be GL active texture, not GL texture active. Yeah, we need to fix that. Class texture 2D. Okay, we have some errors here. Let's see. Yeah, we don't require to specify the path here this way. So let's remove that. After binding, so that's not the requirement. Yeah, done. Yeah, the texture 2D class is working all right. I'll just show you all the output. I hope you can see it. Yeah, so this is basically a simple brick texture, nothing too fancy. I was just working with the texture 2D class and I just got it working. It's working all right. So let's move on to cube maps maybe. Let's add a method to process input. We'll be using GLFW to handle input here. Guys, I'll be right back in some time. Till then you can enjoy some music. So hello, we are back, and last time we just implemented our texture 2D class or OGL wrapper for texture 2D, and now let's work on creating a cube map. So cube map is nothing but it will consist of 6 different textures, single textures. So let's create that. Or let's name it texture 3D. That would be better. We'll write unsigned int for the ID. We need the name, and also we'll require the type. Let's create a constructor for that. So texture 3D is nothing but a abstraction for loading cube map. So here we specify the name of our cube map. Let's create a destructor, then bind and unbind methods. Let's name this load texture, and as an argument we'll accept a vector of strings. Let's copy these methods because these are going to be just the same. Or maybe later we can just create a generic texture class and we can use polymorphism to derive from that and create texture 2D and texture 3D. But right now let's leave it at that. Hi Berke, I hope I am pronouncing your name right. Berke, you could use the OpenGL Redbook, and there are many tutorials available on YouTube. You can watch those. But if you prefer these tutorials in Turkish, I am not sure about any resource for that. But I am also working on my own OpenGL series, where tutorial series, where I will explain all the OpenGL concepts in depth, and will also go in depth into the mathematics involved in shaders, lighting, the lighting math, like the BRDF functions, the distribution functions, microfacet theory, and all those interesting topics in PBR shading and everything. But it will take some time. Right now I have a simple concept explanation on FBOs on my YouTube channel. You can watch that. And I have one blog written about using IMGUI for immediate mode rendering of UI on my website. I have pinned my website in the comment section. You can check that out. And Berke, we are also planning to create a Discord server, a community for uh, graphics programming enthusiasts, where maybe uh, you'll be able to discuss any issues that you face while learning OpenGL and throughout your graphics journey. So Berke, are you working on any OpenGL project right now, or any game project using any other engine? Feel free to share. We'll also have to set the we'll have to flip the texture vertically uh, while loading a 2D texture, and we'll have to disable that while loading a cube map or a 3D texture. Otherwise you'll get some strange results. So let's do that. And we'll set the same thing to false in our load texture method in texture 3D. Hi Moin, how are you doing? Welcome to the stream. The guys who have just joined, do you want to see the current progress of my engine? Right now we are just refactoring and rewriting some modules, but I have a built version as well. If you guys want to see, then I can show the current progress of the engine. Let me know. Yeah, Moin, I'm using Linux. We don't require to use MIP maps in cube maps, so we are not enabling that option here. That's perfect, Moin. Like you should like try switching to Linux. You won't break your system. Like first you'll have to create a bootable USB. Maybe try a simpler, Debian based distro, and then you can switch to some other. Currently, I have Linux Mint and Arch Linux dual booted in my system. I would suggest maybe you could try Fedora or Linux Mint. Those are a bit on the user friendly side, and just get their ISO images, create a bootable USB, and maybe if you are scared that you might break your OS, your existing OS, what you could do is like you could create a bootable USB with that OS with persistence. So you can use that secondary OS when your USB is plugged in. That way you won't destroy your main OS, like in case if you mess up. You should try, because Linux gives you so much of freedom and customizability that if you go in depth, you'll really learn more about computers and operating systems and how things work under the hood. You should definitely give it a try. Let's set parameters here. Uh, Guys, if you're watching, don't forget to subscribe and leave a like on this stream. That would keep me motivated to do more such live streams. Okay, we have that in place. Now we need to write these methods. We'll just copy those from texture 2D because they are more or less the same. Yeah, that's a great choice, Moin. Like, Linux Mint is great. I have been using it for a long time now. Later, you can try switching to Arch Linux. It is really cool. I think the texture 3D implementation is done. Maybe we should add some getters as well for the ID. Let's do that. Bye, Moin. See you later. Let's try sampling a cube map. We'll have to specify the vertices for that. I think, guys, I'll end the stream right now, and we'll continue our remaining tasks in our next live stream. And in our next live stream, I'll be sharing Discord server link maybe, and that is where we can connect and share resources and help each other out while learning. And yeah, we'll be working on PBRs and all after I complete this refactoring. I'll also be working on this off stream, and I'll keep you guys updated. And let me know if you guys want some OpenGL tutorials and in-depth graphics concept explanations. I'll be uploading those videos soon as well. So thank you guys so much for watching the stream. See you guys next time. Bye.